So good morning all. Today we are going to see something about nano sensors. So in the initial stage, I just wanted to give a brief about nanotechnology. What is nano? Then enter into sensors and complete with nano sensors and a little bit of research work which is going on nano sensors. And to be frank, in our country, the development and the research work is comparatively little less. And now we have started a lot, even in reputed institutions in Tamil Nadu. We have nanotechnology labs where you can request and do the work. And it is a wonderful area where you can do a lot of work because at present, this nano sensors, the nanotechnology is implemented in all engineering field. So we'll enter to the session. So first, why we have to learn about nanotechnology? As I told you, the future is totally on nanotechnology. A picture of nano is as shown. It depends upon the material. So the color and the structure changes. There are different. So just we are familiar with coronavirus. I just wanted to show the structure of nano here. So what is nano? So normally when we talk about nano in India, everyone, engineering people especially, and the people who love the car, we all know that there was a car introduced by Tata called a Nano. So that name was named only because of this nanotechnology, the smaller in size. So it means that the size is reduced. So it is around a billionth part of meter. So nano symbol is N, is the unit prefix of meaning 1 billionth. For example, if you compare a sheet of paper is about 100,000 nanometers thickness. So you can just imagine the nanoparticles. So nanometer is a measure of length whose symbol is nm. It is a unit equivalent to 1 billionth of meter. And a nanoparticle, ultrafine unit with dimension measured in nanometers, is 1 power 10 power 9 meters. And nanoparticles exist in the natural world and are also created as a result of human activities. So there are nanoparticles already available, and according to our application, we or as engineers, we are creating our own nanoparticles which can be used for different applications. So because of their submicroscopic size, they have unique material characteristics, and manufactured nanoparticles may find particle application in variety of area, including medicine, engineering, catalyst, and environmental. So if you compare with other things, atom is 0.1 nanometer, DNA 2 nanometer wide, protein is 10 nanometer long. So these are some example 9 nanometer tall. So always we know about the Empire State Building. Now we have Burj Khalifa and things. In olden days, we used to talk only about this Empire State Building. So it is around 3.81 into 10 power 11 nanometer tall. The nanoscience, physics, Richard Feynman, the father of nanotechnology, is called as the father of nanotechnology. Nanoscience and nanotechnology are the study and application of extremely small things and can be used across all the other science fields. So we know that engineering was born from the science, and science was born from the arts. So engineering field totally now depends upon the science field, the basic, such as chemistry, biology, physics, material science, and engineering. Nanotechnology has given us the tool to play with the ultimate toy box of nature, atoms, and molecules. Everything is made from it. The possibility to create a new thing appear limitless. He's a Nobel Prize winner, Stromer. Sorry. Application, including titanium dioxide in the sunscreen, cosmetics, and some food products, silver nanoparticles in food packing, clothing disinfectants, and household appliances such as silver nano, carbon nanotubes for sustained resistance, textiles, and cerium oxide as fuel catalyst. So these are some nano materials which are used in applications. What are the different applications? Nanotechnology in medicine. Whatever it is used, whether it is used in medicine or wherever it is, the device or the technology is implemented by an engineer. So the engineering people have scope in all the field, including now we call it as medical field. But even in medical field, the technology that has improved to do such automatic operations and minute sensors which is going inside the body to study about the body, everything is controlled and manufactured by engineer. So we should be proud to be an engineer, that we are ready to work for all the field. So in medical field, medical use of nanomaterials, drug delivery, cancer, surgery, tissue engineering, visualization, it is used. Nanotechnology in the electronics, it plays a very big role. Mechatronics, which deals with machines and robotics, which humanoid, for example, if you take humanoids are now capable of doing a lot of giving an input signal to the humanoid how to operate. That input signal is taken to the brain called artificial intelligence, which it can perform its own task. But the main situation here to control the humanoid, it is totally based on the sensors which is giving the input signal to the humanoid or the robo, which you call, to perform its task or according to our need application. So these, there are different types of sensors. We know that depending upon the application we use it. In that we have now nano sensors, which is capable of reading even a very nano movement of things. So in nanotechnology electronics way of improvement, allowing more transistors to be packed into a single chip, allows a higher electron mobility, a higher dielectric constant, faster frequency, single electron transistors, using electrodes made from nanowires, using nano-sized magnetic rings. Nanotechnology in computers. Computer processors are more powerful. Ultra high density memory, silicon transistors are replaced by transistors based on carbon nanotubes. Size of microprocessors are reduced to greater extent. Memistors material as future replacement for flash memory. In field of energy, creating device smaller than 100 nanometers gives us new way to capture, store and transfer energy. Increased efficiency of lighting and heating, increased electrical storage capacity. It is a very big requirement for us all over the world. Even if we are capable of producing a lot of electrical power, the problem in the world which is facing is to store the energy. So storing of energy, especially in electronic people, you would have studied about this fuel cells and things, which is creating. And next level of storing materials. So material which electronic device can store for a long period. So normally we know the batteries are there, lithium and liquid batteries, dry batteries, and all this. In this format, the power can be stored, but not for a very long period. It can be stored for a limited period. So the lot of research is going on in this storage, and storage of energy is a very good area where you can take your research work. And in sports field, reducing the rate which air leak from tennis balls, so they keep their bounce longer. Nanomaterials used there. Golf ball to fly straighter. Bowling balls become more durable and have harder surface. Food industries in food area, nanotechnology is having an impact from how to food is grown, how it is packed. Companies are developing nanomaterials that will make a difference not only in taste of food but also in safety. For example, if you take a simple concept which we use masala powders at home, it is also a format of nanoparticle. If we get chili, we turn it into nanoparticle, which mixes with the curry so that you get the taste. Like all grains which we use, it is also a nanoparticle. Zinc oxide nanoparticle can be incorporated into plastic packing to block UV rays and provide antibacterial protection. improved strength and stability of plastic packing. So these are the total applications where the nanotechnology is used: entertainment, defense, textile, agriculture, information technology, materials, telecom, medical, chemical field, chemical industries, energy, production and distribution, aerospace, autumn activities. Everywhere we use nowadays the nanotechnology. Application in the field of mechanical engineering, biomedical and engineering, fluid mechanics, for heat transfer, better heat transfer and things, we use nanofluids. Combustion and the environment, to reduce pollution, we use ground vehicle system, sorry, heat transfer, thermodynamics and energy system, manufacturing, mechanical design, system dynamics and control, transportation system. Applications of nanomaterial, next generation computer chips, kinetic energy, penetrators with improved lethality, better insulation materials, phosphorus of high definition TV, low cost flat panel display, tougher and harder cutting tools, elimination of pollutants. So this is the comparison of the nanoparticles, which is shown with some different things. So for example, an ant is 5 mm, which is almost 10 power minus 2 meters. So when you compare with nanoparticles, the nanoparticles which we imagine, for example, dust mine, if you take, normally we cannot see a dust mine. Comparing to that also, dust mine is 200 micrometers, and nanoparticle are more smaller than that. So this PPT anyhow I'll be giving as a PDF, so that it will be shared. You can go through all this, because there are around 138 slides. So if I'm explaining all too much, it may take 2 hours or 3 hours. So I'll be moving little fast, and in between, if you have doubts, you can note it down and keep. I'll be putting my email ID in the chat box, so that any doubts you can mail me, and you can ask me. So nanotechnology, history: in 2000 years ago, they started nanocrystals from Greek and Romans to dye air. And 1,000 years ago, gold nanoparticles, which are coloring stains of glass windows. In 1959, the first concept discussed by node physic Richard, the father, who we talk, plenty of room at the bottom. In 1974, nanotechnology, for the first time they implemented, and in 1981 IBM develops scanning tunneling microscope. In 1985, a scientist Rice University, they did Sussex discovery of C60. In 1986, nanotechnology was implemented as a book, and in 1991, carbon nanotubes discovered by small image. So these all are the small history. Again, we will be having some little more brief. So nanotechnology is a field research of innovation concerned with building things, generally material and device, on the scale of atoms and molecules. The nanometer is 1 billionth of meter, 10 times diameter of a hydrogen atom. The diameter of human hair is on average of 80,000 nanometers. So it is all just giving you an idea about how small a nanoparticle is. So this is the next scale, which is showing you the level of nanoparticles. So what is nanotechnology? A shortened nanotech is the understanding and controlling of matter at dimension of roughly 1 to 100 nanometers. A nanometer is 1 billionth of meter, the width of 3 or even now the electronic devices made in movies, which all are made with nanoparticles and nanotechnology. So metric scale of this compared with milli, micro, nano and pico. So nano is 1 power 1 into 10 power minus 9 meters. So macro, micro and nano, the comparison which is shown here. So a person 6 feet tall is around 2 billion nanometers. So these are DNA. If you take it as 2 nanometer. A structure of nanomaterials, size and shape, which is shown, which you can use it for studies 0D, 1D, 2D and 3D bulk. And applications where it is used. It is also shown components in wave guiding, photocatalytic activities, the things which we use, and different types we call is nanoparticles, rods, wires, tubes, nanofilms, nanocoating, and nanocomposites. So talking about sensors within the nanotechnology field, there are many subcategories, one of which being nanosensors, it and conveying it to the another electronic controller, which is going to activate the sensors. So it can be a different types of sensors based on the application. So sensor is a very important device which is going to feed the system the input, and that input has to be converted by the controller or embedded system, and it will be controlling the total device to do the particular task. So sensors can be classified either based on signal production or by different methods. They employ through a number of approaches. There are presently three mechanisms, that is electrochemical detection, optical detection, and acoustic or mechanical detection. Nanosensors are essentially the result of combining nanotechnology sensors. So here we are converting that into a nanosensor by reducing the size as small as possible, which is called as a nanosensor. A nanosensor can be defined as a device that communicates information about behavior of particles at the nanoscale level uh, to the microscopic level, where it is visible to the naked eye. So that is one advantage of this nanoscale technology. Nanosensor is a improvement in sensor technology, which is based on the use of structures provided by recent advanced in nanotechnology, such as nanowires, nanotubes, and nanoprobes. So these are some nanosensors which you can see, which is kept on a finger, so which are used for different application. Why are nanosensors important? Compared to the conventional sensors, they are commonly used in right now. Nanosensors are faster or significantly smaller, making them more portable. And because they are so small, they make less of an impact on the phenomenon being measured. So the accuracy is also going to be good. They require less power of function. So input energy which is given, the power can be reduced. Nanosensors have great sensitivity. As I told you, the accuracy and sensitivity is good, which allows them to be more accurate. Nanosensors have faster response, which enables the possibility of real-time analysis. The aforementioned benefits of nanosensors brings us a new kind of possibilities at the nanoscale level. Detecting airborne chemicals. Chemical nanosensors enable the monitorization of chemical in the air. This could help detect dangerous chemical or help measure the level of pollution in the air and inform scientists of how to react accordingly. So this is a very good sensor which is used in pollution control. Measuring temperature. Nanosensors allow to allow us to measure the temperature of living cells and nanofluids using nanometers. measuring the temperature of living cells, which could really reveal how particles at the nanoscale level react compared to the bulk material. Up in electronics, this and is also cooled by nano. So we call micro. You would have here we have MEMS to cool smaller devices, including where nanotechnology, nanosensors are very in micro scale to find it soon, detect if some of the virus, just breathe on the nanosensor, we can nanosensors will then be able for medicine because organizing of patient treatment to start immediately because they have between the nanoscope the microscopic world. We now are able to interact with the understand the particle. Nanosensors are opening doors technology, helping to solve some of the problems on earth trees, environment, biomedical, military, smart office managed to signal that can be detected and analyzed. So these are some different types of nanosensors which are used for different applications like PC, industries, agriculture, military area, everywhere. How nanosensors work? Yeah, analytic sensor, transducer, and detector are the components of a sensor system which feedback from the detector to the sensor. Sensitivity, specificity, and easy of execution are the main goals in designing a sensor. Working nanosensor work by converting the absorbed material or a process into electrical signal which can then be analyzed. Most nanosensors work by measuring electrical changes in the sensor materials. So when we talk about nanotechnology, any application, either a nanosensor or wherever it is used, the main thing, the study goes between the materials. So the material plays a very big role in creating a nanosensor or nanotechnology things. Nanosensor detect change from external interaction and communication to the other nano components. Nanosensor, like every other sensor you see in your daily life, like regular sensors, nanosensors sense and detect different signals in a variety of environments. They can detect different signals including biomedical, electrical, optical, physical, and mechanical signals. So history, as I told you, father was there, and then comes Walter, his research in IBM, which they made a nanoprobe in 1990 in his own company. And after further breaking development, nanoprobes become the first company worldwide to satisfy the emerging need of high quality AFM sensors. So is Richard Feynman is the father of nanotechnology. So AFM is automatic force microscopic, and the scanning force microscopic also microscopy is also there. We call it as SFM. Automatic force microscopy is a type of scanning probe which demonstrates a resolution on the order of fraction of a nanometer. more than 1,000 times better than the optical diffraction limit. The information is gathered by feeling or touching the surface with a mechanical probe or piezoelectric element that facilitate tiny but accurate and precise movements of electronic command enable precise scanning can be done. So this is a small peek of your AFM. So nano geometries. So nano geometries in different structures are there. Geometries are there: bulk, cavity, networks, structured surface, slit, planar surface, particles, shell, spheroids, spherical shell, rod, tubes. So any type of structures, geometries can be used for nanotechnology, nanosensors. If you well known as a mobile phone nowadays, which we use on a cool floor, you can keep it so it may get little cool. Keep closer to AC. All new mobile phones are with high configurations, and it is getting too much hot. The components are working 24/7. The electronic devices to be cooled. So can plan on research for this. So there may in future the mobile phone may be more thinner with more nanoparticles, but the heat capacity has to be designed well. The cooling performance especially. And nowadays, normally when you see the mobile phones, it is totally sealed because they need to give it as a water resistant and things. So you don't have even a small air gap. So normally we know that air is best media which cools all devices. Since there is not even an air gap, the air has to be flowing on the mobile. And normally when you see a mobile, it is all not with any rough surface to restrict air and cool the device. Everything is very smooth. So there may be a easy airflow. So there may be no cooling from outside source. So normally the mobile has to be cooled inside itself. So it has to be a nanotechnology where it can cool the device. The basic principle behind liquid cooling in smartphones work on dissipation of heat. The cooling system consists of heat pipe with the liquid inside. So this has to be implemented with nanotechnology. This liquid becomes a vapor by absorbing the heat from the chipset. The heat is further dissipated and the ambient temperature is maintained. Nanoelectronics. Nanoelectronics refers to the use of nanotechnology in the electronic components. The term covers a diverse set of devices that materials, which with the common characteristics that they are so small that interatomic interactions and quantum mechanical properties need to be studied extensively. Use of nanosensors. Nanosensors are chemical or mechanical sensors that can be used to detect the presence of chemical species and nanoparticles, or monitor physical parameters such as temperature on nanoscale. They also find use in medical diagnosis applications. Nanosensors is a chemical or physical sensor constructed using nanoscale components, usually microscopic or submicroscopic in size. So there are active nanosensors and passive nanosensors. Active nanosensors are nanosensors that have ability to send a signal which could be received remotely. Passive nanosensors, they are change in color and opacity of fluorescence. So it could be also be a sensor that will detect the presence of nanomaterial or molecules in the nanometer size range or small. So types of nanosensors basically classified like optical sensors, proximity, ambient light, biological sensors, antibody, DNA interaction, enzymatic, chemical sensors, chemical compositions, molecular concentrations, physical nanosensors, pressure, force, mass, and displacement. So this is a basic classification of your nanosensors. So types, there are different types of nanosensors in the market developed by various applications, most notably for defense, environment, and the healthcare industries. These sensors have same basic workflow, a selective binding of analytic signals generation from the interaction of the nanosensors with a bioelement and processing of a signal into useful metrics. So example of useful nanomaterials for different types of applications like if you take environmental and water remediation, iron, polyethylene, carbon nanotube, graphene. So agri or agrochemical, silica and carriers, food packing, gold, nano, titanium dioxide, silver, etc. Composite materials, graphite, carbon tube, nanotubes, things. And nanosensor types carbon nanotube based on fluorescent nanosensors, and quantum dot based on fluorescent nanosensors, DNA based fluorescent nanosensors, peptide batch based fluorescent nanosensor, plasmon coupling based nanosensors, plasmonic enhancing crunching based nanosensors, resonance imaging image based nanosensors, and multimodal nanosensors visual challenges. Property and optical property are there. Property which gives the sensor required controller, and optical normally depending upon the light or the temperature and things which can be easily measured, and it can be sent to the control. Paramagnetism, and ferromagnetism and or magnetic nanosensors. And optical nanosensors shows a presenting reaction of electromagnetic extraction of optical execution of optical frequencies. The change of the optical properties can be integrated in contact-free macro world. So, and the example is hello, am I audible?
Sir, it's audible,
Hello,
sir. Yes, sir, audible, audible.
hello,
Sir, it's audible, sir.
hello,
Sir,
hello,
Sir, it's audible, sir.
hello.
Sir, Professor, sir, can you hear me?
Yeah, the ma'am, yeah, ma'am, you can mute it. It is giving some disturbance. You can mute your.
Ah, okay, sir.
Okay, ma'am. So nanobiosensors of detection of nitro oxide via the fluorescence directions of catachrome or catachrome C, or fluorescence of label catachrome C are used. Silent features, fast response in time, and the detection limit is 20 micrometer. How are nanosensors built? Most nanosensors work by measuring electrical changes in the sensor materials, that is nanomaterials, as I told you. For example, if a molecule of nitrogen dioxide comes into contact with chemical carbon tube nanosensors, it will strip an electron from the nanotube, that is the nanomaterial, which will make the nanotube less conductivity, which gives an output there. There are several ways proposed today to make a nanosensor. This includes top-down lithography, bottom-up assembly, and molecular self-assembly. So currently, to build a nanosensor, there are two dominant methods: the top-down nanofabrication and the bottom-up nanofabrication. So top-down is the left side which you see, which you have to bulk to fragments. And here, when you come to bottom-up, it is atoms and clusters. top-down approach, the physical is the use of photons, that is optical lithography, electrons, electron beam lithography, and ions, ion beam lithography, which will, while the chemical top-down strategy is essential on chemical reactions that are brought about by chemical reactions. So the agents that can be used are acid and bottom-up assembly. Bottom-up assembly modeling is a part of centric modeling method, where the assembly design is started with principal structure of not the PAL, structure of relatively isolation from overall assembly. So molecular self-assembly is assembly of molecules without guidance or management from outside source. Self-assembly can occur spontaneously in the nature. For example, in cells, such as self-assembly of lipid bilayer membrane. It is usually result in an increase in internal organization of system. Top-down nano fabrication. So these are the methods which are used for top-down. That is templated etching, selective dealloying, and anisotropic distillation, and the thermal deposition. So these are the methods where you can fabricate by using top-down method. So these are the nano sensor, which is shown in a bigger size to see it clearly with carbon nanotube. So any small external force, the force also you can tell it in nanos, like, so which acts there, which will give a deformation and which gives your input to the sensor, which will be given to the controller. So in that you have different category. One is CNT based FET transistors, physical nanometer or nanosensor, biological nanosensor, and a chemical nanosensor. So these all depends upon the input signal which is going to act on that. So approaches of nanotechnology: top-down approach and bottom-down approach, as I told you. So you get nanoparticles. So atoms and clusters are converted into nanoparticles, or bulk is powdered and converted into nanoparticles. The next is top-down approach. This seeks the create smaller devices by using larger ones to direct their assembly. Usually top-down approach is used less than bottom-up approach. Solid-state silicon methods, they can create feature small than 100 nanometer. So bottom-up approach, as we saw, sorry, assembling nanomaterial atom by atom or molecule by molecule. That is self-assembly. This approach is much cheaper. Things become much larger. Example of molecule self-assembly or Watson quick base pairing and nano lithography. So this is the designing of the nano particles which is used for sensors, analytic bioreceptors, and nanoparticle used, and transducers. So according to the application, you can select the different types of nanoparticles and different types of transducers and different types of bioreceptors. So nanoparticles, nanomaterial comprise material nanoparticles, metal nanoclusters, metal oxide nanoparticles, metal and carbon quantum dots, graphene, carbon nanotubes, and nanocomposites. Sensors includes electrochemical nanosensors, optical nanosensors, electronic nose and electronic tongue, nano barcode technology, and wireless nanosensors. The sensitivity of this sensors is due to unique electrochemical, optical, Raman effect, we call Raman, and the catalytic and the super paramagnetic properties. They can detect food contaminants such as preservatives, antibiotics, heavy metal ions, toxinics, and microbial load and pathologic. They can also monitor temperature, traceability, humidity, gas, and aroma of food stuff. So these are the different organic nanoparticle structures, polymeric nanoparticle, sorry, and liposomes, dendriners, carbon nanotubes, gold nanoparticles, quantum dots, iron oxide nanoparticles, So these are some different types of nanoparticles and their structures. So this is the same another one which I am showing. So these are the structure of this nanoparticles. So current nanosensor devices, nanostructured materials, example is silicon, nanoparticles, nanoprobes, nanowires, nanosensors, nanosystem, okay, which are used in names and all. For silicons, I don't want to talk much about the history and things. So classification here, nanosilicon, mesosporosilicon, microporosilicon, and pores generated to electric breakdown. So there are some nanometers which is given there for the different type of porous silicons, that is nanoporossilicons. Sorry, silicon based nano particle which is shown here, alloy of Cu, copper and Si, or lithium and Si, and the size is around 10 nanometer dia. Nanoprobes, pebble probes, a probe embedded by biological localized encapsulation. So spear shaped is around 10 nanometer, and pH and calcium, magnesium, oxygen, potassium. So these are the things which are combined there. So this is the assembly method of nano particles to make nano device. So here they are making a film over nanosphere. So nanosphere lithography fabrication of nanoparticle array and film over nanosphere surface. They are generating with nanoparticles. Major types, there are two major types of nanosensors, mechanical nanosensors and chemical nanosensors. Identify the movement of while chemical sensors test chemical concentration. Both nanosensors work by detecting change in electrical conductivity of a material. Nanosensor detection limit for different analysis of surface, enhanced Raman spectroscopy, LSPR. So detection method and nanomaterials, which is given in the list. So once you get the PDF, you can just go through that. So next, the transducers. The transducer is linked to read out the system, which transform or amplifies the measured signal into understandable information for the user. So this, when we go with nanotechnology, the transducer also has to be manufactured with nanotechnology, which is going to read out it accurately. So sensor's main element or recognition element, the transfection element, the sensor receiving input from the sample, which is converted into a signal. If the recognition element is a nano material, at least one dimension is between 1 to 100 nanometer. You obtain a nano sensor. Electrochemical sensors can be used for numerous analysis, like electrical recognition is quickly expanding field with built-up basics and minimal effort in manufacturing procedure. The most common used nanomaterial is silicon nanowire because they possess high sensitivity and easy for functionalizing the or chemically modifying on the surface. Electrochemical detection approach have different subtypes on the base of signal type, like potentiometer, voltmeter, amperometer, and electrochemical impedance spectroscopic. Sometimes electrochemical measurements are conducted with immunoassays and resulting sensors called immunosensors. These categories depends on the produced and amplified signal type. So electrochemical sensors, nano sensors based detection of electrical signal first and foremost reported nano field effect. So you would have studied about FETs. So possess tunable properties and can be responsible for easy and quantitative measurements. And chemical sensors based FET principle utilize rod shaped nanomaterial, nanowires and nanorods or nano ribbons, and the nano towers and the nanotubes. When targeted, we can analyze the clinging of activities of area. This results in change of impedance and produces a signal. A nanomaterial these micrological provides increase in sensitivity and activity area current flow compared to the activity across the cross section of other nanoscale, and monoplogic on the flat detector surface. Optical sensor detection of nanosensor provides high sensitivity as a result in detection connection of nanomaterial light signal However, sensitivity is stronger or strongly depending on the detection mode of the optical phenomena. Optical sensors are used for several different types of spectrographic analysis, like absorption, visible radiation, fluorescence, Raman surface of enhancing Raman scattering, and refraction and qualitative analysis using dispersions. An example of sorry, optical signal transduction is the quenching of fluorescence by gold nanoparticles, AU NPS. And the fluorescence from fluorescence is histolic cantons, that is FITC, that moves closely to gold nanoparticles, is extremely quenched, and now non-visible radiation signal is detected. The same molecule is close proximity to this nanoparticles, exhibits increased Raman scattering signal, and thus behaves like a Raman probe. So chemical nose sensor, we studied different types of sensors, and that one is called a nose sensor. So graphic representation of gold NPs and interaction with fluorescent polymer. When this fluorescent polymer intermingles with gold nanoparticles, the fluorescence is quenched. When the targeted protein attacks the displays, the polymer fluorescence is restored. So mechanical sensors, as because of force, normally we use here. Mechanical nanosensors are made up of nanomaterials. Whenever a nanomaterial is physically manipulated, its electrical conductivity changes. This change invokes a response that can be measured using an attached capacitor, because the physical change causes a quantifiable change in capacitance. So mechanical detection system based on nanoparticles, there are many, just go through one. Mechanical detection system based on nanoparticles allows ultra sensitive detection and measures the change in mechanical force of molecular level. So for example, enclosing fluid filled channel into a cantilever is one option to measure the fluid. And chemical nanosensors are made up of nanomaterials. The electrical conductivity of the nanomaterial is reduced whenever a molecule absorbs to it. So chemical nanosensor test the electrical conductivity of nanomaterial and measure it whenever they detect these changes. Some example of chemical nanosensor includes nanowires and nanotubes. So nano cantilever based sensor have these things called the cantilevers, which sticks out to the sensor like a tongue. So the movement of that cantilever gives the sensing part to the input to the sensor, and which is going to be sent to the controller for the controller to response. When a cantilever encounters different things, it will behave accordingly. If there is heat source, it will bend upward. If there is a surface tension, it will bend slightly. Pretty simple. To collect data, scientists use benchmark and graphs. So this is a cantilever based sensing device, which is shown in the figure. Nano cantilever based sensor. Nano cantilever based sensor are also used in the medical field, but instead they are called the nano cantilever based biological sensors. So normally these nano sensors, which are used in medical field, are generally called as biological sensors. Just a minute. So they are also called as biomedical sensors. These detect and sense biomolecules. Instead, the resonance frequency or cantilever will change when it encounters certain molecules. So molecule change, biomolecule change, which will be happening in this biological sensors. Graphene hydrogen vapor sensor, which is used normally, people using nowadays, we use this Apple Watch, Fitbits, which is tracking your body. So these kind of things, even based on the vapor and the sense, the sweat vapor and things, you can get signals. So these kind of things are sensors, which are nano sensors, which are used in your devices, which reads your body physical changes. What is a nano biosensor? The biosensor is a measurement system for the detection of and analyze that combines the biological component with a physicochemical component Detects and nano biosensor is a biosensor that on the nano scale size. So biological details which is collected by a sensor is called a biosensor. So living biological cells, tissues, whole organisms, metals, molecular species, antibody, enzymes, proteins, everything can be studied. Classification of nano biosensors is nanoparticle based sensor, nanotube based sensor, and nanowire based sensor. Acoustic waves biosensor, magnetic biosensors, and electrochemical biosensors. So what is 100 times stronger than a steel, yet lighter than an aluminum? Just think, carbon nanotubes are among the strongest material ever discovered, yet engineers are only just starting to unlock their full potential. So this carbon nanotubes are now very much used in study of nanotechnology and nano sensors. Nanotube. A nanotube is a nanometer scale tube like structure. It may refer to carbon nanotube, silicon nanotube, boron nanotube, inorganic nanotube, DNA nanotube, and membrane nanotubes. Carbon nanotube production exceeds several thousand tons per year, used for application in energy storage, device modeling, automotive parts, boat hulls, and sporting goods, and water filters, thin film electronics, coatings, actuators, and electromagnetic shields. The carbon nanotube are an allotrope of carbon, meaning that they are one of the several possible arrangement of atoms that carbon can take. In nature, pure carbon is found either in form of graphite, a soft flaky solid, or diamond, which is transparent and hardest naturally occurring materials. So this can be converted into nanoparticle and can be used. So carbon nanotubes are more closely related to graphite than diamond. Tough graphite is very soft. Though graphite is very soft, it is constructed of layers of carbon atoms arranged in sheets, one atom thick. These individual sheets are called graphene, and carbon nanotubes are what you would get from the rolling of graphene sheets into a shape of a tube. So we get carbon nanotubes. So these are some different types of carbon nanomaterials and nanotube. So graphene nanotube you can see here, and different types, other types are also the particles of nanoparticles. So the research based, if you take MIT engineers have built a modern microprocessor from carbon nanotube, field effect transistors pictured there, which are seen as faster and greener than the silicon transistors. The new approach used the same fabrication process used for silicon chips. So now many of this MIT Manchesters and other college people and all, they started working on much of nanotechnology. Schematic summary of the kind of quasi-1 dimensional metal oxide nanostructure is shown here. So A is your nanowires, nanorods. So like this, there are different types. So you can see once you get the PDF. And next is just a recall. We'll go a little faster. The concept, what we studied is nanometer, nanotechnology, history to just remembrance, application, sensors, nanosensors, importance and working types and applications, nanostructures, geometries, and nanoelectronics, use of nanosensors, types of nanosensors, nanomaterials, nanosensor devices, and nanosensor fabrication method, and nanobiosensors, and types of nanobiosensors, and carbon nanotubes. So types of nanosensors, physical, chemical, and biological things are there. In research and development, research at IIC, Indian Institute of Science, have developed a highly sensitive, low-cost nanosensor that can quickly detect minute change in carbon monoxide, CO level, with potential application in environmental pollution monitoring. So this has been done by IISc, Bangalore. The new sensor developed at UG Berkeley can be made into a smart wristband or a headband that provides continuous real-time analysis of the chemical in sweat. So by studying that, you can check your body quality. User wearing flexible sensors arrays can be used. So this is one more. And nanosensors MSS for gas odor sensing. So which can even sense the gas odor if it is even a very less. In case even in your house, if there is leakage in gas, it can sense and give you the output. So engineers imagining new possibilities in manufacturing, fluid mechanics, robotics, combustion, biomedicine, measurements and heat transfer and more. With these tools, mechanical engineers conduct world-class research in nanoscale manufacturing, micro and nano fluids, and in much in electronics and electrical field. Nanos devices are very much used for applications based on the requirement. Nanosensors are the latest detection technology, driving convenience, routineness, and the portability of pollutant analysis in many sectors, including air and water quality measurements, food analysis, strategy purpose, and the quality control assessments. Recent research, app sensors have shown an excessive assurance in protein sensing with high sensitive selectivity and low cost. So we know that in our body we have to check all this. So there we started using nanosensors. Sensitivity and specific potassium nanosensors. There the research is going on. Intelligent packaging system. Sensors and nanosensors to monitor food quality and safety. SWNT based sensors for wireless detection of explosive and chemical warfare agents. Electromagnetic wireless sensors networks. And graphene based nanosensors and smart food packing system. They use graphene, food safety and quality monitoring. Development of two-dimensional transition metal diaclins based nanosensor platforms. Carbon based nanomaterials for development of sensitive nanosensor platforms. Advanced nanomaterials for inexpensive gas microsensors and nanosensors. And other area where research is going is semiconductors and nanocrystal. So there very big research is going in the semiconductors based nanosensors and metal ion sensing. Antibody nanosensors, nanosensors in environmental analysis. Integration of nanosensors into a sealed microchannel in hybrid lab of chip devices. As I told you, this microchannel cooling is very upcoming and we need only nanotechnology there. Nanosensors for tracing explosive detections. A selective nanosensor device for exhaled breath analysis. So alpha, beta, gamma following sections were fabricated by using spin coating and AU deposition technology. So you get around 30 nanometer shell and 60 nanometer shell and with a different combination of shapes. So glass, AU film, core shell. There are three categories which you can identify that. So one more thing, there is called a multimodal nanosensor. The schematic multimodal nanosensor, which a platform TE transfers electric mode detection, TM transfers magnetic mode direction and a phase shift. And you can also check the delay or advancement in that. So metal oxide nanosensors, we'll skip this much. Application in micro manufacturing, biological injection and nanosensor assembly. The research is going on. Self-powered nanosensors and nanomaterials. Nanosensors for space application is also a very big area that research is going on. So this are some research or system and references and the future, like what is going in that research. So this you can check with the PDF, so which you can give you a small literature, not a very big. It is a very small literature which is giving on which area or how we can do some research on this nano area. So this is some based on oxide-based nanosensors. People who have done a lot of research. You can go through this. This I'm just giving an example so that you can search more, Google more, and find more references. And I have to tell that this area is a very good area to work with. So from MIMS to NIMS, that is micro to nano. So it is first we call it as a micro electromechanical system. Now we started calling it as nano electromechanical system, which the structure is very small compared to the micro system. So process such as electron beam lithography and the nano machining now enables semiconductors, nanostructures to be fabricated below 10 nanometer. It would appear that technology exists to build any NIMS. Challenges for NIMS. Communicating signal from nanoscale to microscopic world is a small challenge which we can do some research on that. Understanding and controlling microscopic mechanics and developing methods for reproducible and routine nanofabrication. So conclusion, existing nanosensors have realistic applications. Current nanosensors are still based on microsensing technique that are enhanced or miniatured to that. Future nanosensors will create perfect situation or shifts enabling nanotechnology, and the future nanosensors will be possible with the development of nano electronics and integratable nano devices. Nanosensors will ultimately have enormous impact on our ability to enhance energy conversion, control pollution, produce food, and improve human health and longevity. Thank you. Ma'am, hope correctly I completed 1240.
Sir, some queries are there with chat box, sir.
Ma'am, queries they can just mail me,
Okay, sir. Okay, sir.
because actually I planned at 12:30. I have to move. It is 12:40. But any small queries, I can immediately check it out,
Okay, sir. Okay, sir. Okay, sir.
because I have to check how many queries are there. I
No
can
problem, sir.
nanos.
No problem.
Yeah, ma'am. Induja ma'am has asked the question. Nano sensors we started using in agriculture. Already there. Even in agriculture, for example, if you want to study about a vegetable or any rice or whatever it is, you can use a nano sensor. It has been already started. It is answer for Induja ma'am.
Okay,
And
sir. Okay, sir.
what about the energy dissipating of nano sensors at the sensor? That is what I told. The energy dissipating is going to be depending upon the application and the work period of the sensor. So cooling is an important device which we have to take care of it. That is what I was telling, cooling as a main area where we have to talk about. It is Jiva.
Okay, sir. Okay, sir.
I think only 2 questions are there.
Okay, sir. Shall we conclude, sir?
Yeah, ma'am. And thank you for all participants, especially for sitting for 1 hour and listening to me. And all the best. I feel that there are a lot of young faculty members,
Yes,
so
sir.
that
Yes.
then this is a good area where you can start your work if you want to do your research. And if you want any guidance or things, you can contact me. I'm just giving my mail ID here.
I hope the participants are gained knowledge about nano sensor. For that, I thank to our research person, Mr. Dr.M.Babu, accepting our invitation and delivered this valuable research. Thank you, sir.
Yeah, ma'am. Thank you very much. And once again, I thank the management principal and the department, head of department, and faculty member for inviting me as a resource person and giving me a chance for this. And congratulations for conducting good FTP. And thank you, one and all. Thank you.
Thank you, sir. Thank you,
And I have
participants.
put my mail ID and contact number in the chat. If anyone
Okay,
wants
sir.
to do further research and things, they can contact me.
Okay. Okay,
Okay. Thank you. Thank you, ma'am. Thank you very much. Yeah, see you.
Thanks, sir. Thank you,
Thank you.
participants. The next session will be start by 1:40. So log in at 1:40. Thank you.